to determine the demand factor for offices in a high-rise building using principles from the National Electrical Code, or NEC, standard. Even if the project typically follows the British Standard, or BS, we can use a methodology based on multipliers. Firstly, we need to determine the zone multiplier, or ZM. The zone multiplier considers the vertical distribution of the offices within the high-rise building. To find the appropriate values, refer to a hypothetical table 4. One of the NEC standards, specifically clause 4. 1.1 for the zone multiplier values. For zone 1, representing the lower floors, the zone multiplier is 1. 0. For zone 2, representing the middle floors, the zone multiplier is 1. 10. And for zone 3, representing the upper floors, the zone multiplier is 1. 20. Secondly, determine the end-use multiplier, or EM. The end-use multiplier considers the type of office space being served. Again, refer to a hypothetical table 4. One of the NEC standard, clause 4. 1.2 for the end-use multiplier values. For general offices, the end-use multiplier is 0. 75. Thirdly, determine the diversity factor, represented by the letter F. The diversity factor represents the probability that all offices will operate at maximum demand simultaneously. Refer to a hypothetical table 4. One of the NEC standard, specifically clause 4. 1.3 for the diversity factor values. For offices of all types, the diversity factor is 0. 85. Fourthly, calculate the demand factor, or DF. The demand factor is calculated using the formula demand factor equals zone multiplier times end-use multiplier times diversity factor, or DF equals ZM times EUM times F. Let's consider an example. For an office located on the middle floors, zone 2, of a high-rise building, the zone multiplier is 1. 10. The end-use multiplier is 0. 75. And the diversity factor is 0. 85. Therefore, the demand factor equals 1. 10 times 0. 75 times 0. 85, which equals 0. 66 approximately. It is important to note that the NEC standard is the National Electrical Code standard used in the United States. However, the principles of calculating demand factors for offices and high-rise buildings can be applied to other standards, such as the British Standard. The demand factor calculated using this method should be used as a guide only. Actual demand may vary based on the specific building characteristics and usage patterns. When calculating the demand factor, it's important to first accurately determine the zone multiplier based on the location of the office within the high-rise building. Lower floors, middle floors, and upper floors will each have different zone multiplier values, reflecting the potential for varying electrical loads depending on the floor's usage. Ensure that the correct zone multiplier is selected from the appropriate table in the NEC standard, which in this explanation is referenced as Table 4. 1. Clause 4. 1.1. Next, the end-use multiplier accounts for the type of office space. Different types of office spaces will have different electrical demands. For example, a general office space will likely have a different demand compared to a data center or a specialized laboratory within the office building. Consult the NEC standard in this explanation referenced as Table 4. 1. Clause 4. 1.2 to find the appropriate end-use multiplier for the specific type of office space being considered. The diversity factor acknowledges that not all offices will operate at their maximum demand simultaneously. This factor is critical for avoiding overestimation of the total electrical load. The diversity factor is based on the assumption that various offices within the building will have different usage patterns and peak demand times. Refer to the NEC standard in this explanation referenced as Table 4. 1. Clause 4. 1.3 to find the appropriate diversity factor for offices of all types. Once you have determined the zone multiplier, the end-use multiplier, and the diversity factor, calculate the demand factor by multiplying these three values together. The resulting demand factor represents the estimated proportion of the total connected load that is likely to be in use at any given time. This value is crucial for sizing electrical equipment such as transformers, switchgear, and conductors to ensure that the electrical system can safely and reliably meet the building's demand without being oversized. The example provided illustrates how to apply these factors in a practical scenario. For an office on the middle floors, Zone 2, the calculation involves multiplying the zone multiplier of 1, 10, the end-use multiplier of 0, 75, and the diversity factor of 0, 85. This results in a demand factor of approximately 0, 66. This means that, on average, only about 66% of the total connected load in this office is expected to be in use at any given time. While the NEC standard is primarily used in the United States, the underlying principles of calculating demand factors are universally applicable. These principles can be adapted for use with other electrical codes and standards, such as the British Standard. However, it's essential to consult the specific requirements and guidelines of the relevant standard to ensure compliance. The demand factor calculated using this method provides a valuable estimate of the expected electrical demand. However, it's important to recognize that actual demand may vary based on the specific characteristics of the building and the usage patterns of the occupants. Factors such as the type of business, the number of employees, the operating hours, and the energy efficiency of the equipment used can all influence the actual electrical demand. Therefore, it's recommended to supplement the demand factor calculation with additional analysis and consideration of these factors to ensure an accurate and reliable assessment of the building's electrical needs. Additionally, consider conducting a load study or monitoring actual electrical usage over time to refine the demand factor and improve the accuracy of future electrical system designs. In summary, calculating the demand factor for offices in high-rise buildings involves determining the zone multiplier, end-use multiplier, and diversity factor based on the NEC standard or other relevant electrical codes. These factors are then multiplied together to estimate the proportion of the total connected load that is likely to be in use at any given time. This demand factor is crucial for sizing electrical equipment and ensuring that the electrical system can safely and reliably meet the building's demand. However, it's important to supplement the demand factor calculation with additional analysis and consideration of specific building characteristics and usage patterns to ensure an accurate and reliable assessment of the building's electrical needs. To elaborate further on the components of the demand factor calculation, let's delve into each multiplier in more detail. The zone multiplier, as mentioned earlier, accounts for the vertical distribution of offices within the high-rise building. The rationale behind this multiplier is that electrical loads may vary depending on the floor level due to factors such as exposure to sunlight, HVAC system requirements, and the type of activities taking place on different floors. Lower floors may have high lighting loads due to less natural light, while upper floors may have high cooling loads due to increased solar gain. The NEC standard typically provides a table or guidelines for determining the zone multiplier based on the floor level or zone within the building. It's important to consult the specific requirements of the NEC or other applicable codes to ensure that the appropriate zone multiplier is selected. The end-use multiplier takes into account the type of office space being served. Different types of office spaces will have different electrical demands depending on their function and the equipment used. For example, a general office space with typical computer workstations and lighting will have a different electrical demand compared to a data center with high-density servers or a laboratory with specialized equipment. The NEC standard provides guidance on selecting the appropriate end-use multiplier based on the type of office space. This may involve categorizing office spaces into different groups based on their function and assigning different multipliers to each group. The diversity factor recognizes that not all offices will operate at their maximum demand simultaneously. This factor is crucial for avoiding overestimation of the total electrical load and for optimizing the sizing of electrical equipment. The diversity factor is based on the assumption that various offices within the building will have different usage patterns and peak demand times. For example, some offices may have peak demand during the morning hours, while others may have peak demand during the afternoon hours. The diversity factor takes into account these variations in usage patterns and reduces the overall demand estimate accordingly. The NEC standard provides guidance on selecting the appropriate diversity factor based on the type of occupancy and the number of units or offices being served. In addition to these multipliers, it's also important to consider other factors that may influence the electrical demand of the building. These factors may include the building's climate, the energy efficiency of the equipment used, the operating IOs of the building, and the presence of any large or unusual electrical loads. It's recommended to conduct a thorough load analysis and consult with qualified electrical engineers to accurately assess the building's electrical needs and to ensure that the electrical system is designed to meet those needs safely and reliably. Furthermore, it's important to regularly monitor and review the building's electrical usage to identify any trends or changes that may affect the demand factor. This may involve installing metering equipment to track electrical consumption and analyzing the data to identify opportunities for energy efficiency improvement. By regularly monitoring and reviewing the building's electrical usage, it's possible to refine the demand factor and optimize the performance of the electrical system over time. In conclusion, calculating the demand factor for offices and high-rise buildings involves a comprehensive analysis of various factors, including the zone multiplier, end-use multiplier, diversity factor, and other building-specific characteristics. By carefully considering these factors and consulting with qualified professionals, it's possible to accurately assess the building's electrical needs and to design an electrical system that meets those needs safely, reliably, and efficiently. The principles outlined in the NEC standard provide a valuable framework for calculating demand factors, but it's important to adapt these principles to the specific requirements of the building and the applicable electrical codes. Remember that the values obtained are estimates and continuous monitoring and adjustments are often necessary to optimize electrical system performance. A key consideration when determining the demand factor is the accuracy of the input data. Inaccurate or incomplete data can lead to significant errors in the demand factor calculation, resulting in either an undersized or oversized electrical system. Therefore, it's essential to gather accurate information about the building's characteristics, the types of office spaces, and the expected usage patterns. This may involve conducting site surveys, reviewing architectural plans, and interviewing building occupants. Another important aspect of demand factor calculation is the selection of appropriate multipliers. The NEC standard provides guidance on selecting multipliers, but it's crucial to understand the underlying assumptions and limitations of these multipliers. For example, the diversity factor is based on the assumption that various offices will have different usage patterns. If this assumption is not valid, the diversity factor may not accurately reflect the actual diversity in electrical demand. In such cases, it may be necessary to adjust the diversity factor or to use a different approach for estimating the electrical load. Furthermore, it's important to consider the impact of future changes on the demand factor. Changes in occupancy, equipment usage, or building operations can all affect the electrical demand. Therefore, it's recommended to periodically review and update the demand factor calculation to ensure that it accurately reflects the current and anticipated electrical loads. This may involve conducting regular load studies, monitoring electrical consumption, and consulting with building occupants to gather information about any planned changes. In addition to the factors mentioned above, it's also important to consider the impact of renewable energy sources on the demand factor. If the building incorporates renewable energy sources, such as solar panels or wind turbines, the electrical demand from the grid may be reduced. This reduction in demand should be taken into account when calculating the demand factor to avoid oversizing the electrical system. The demand factor calculation should also consider the impact of energy efficiency measures. If the building incorporates energy-efficient lighting, HVAC systems, or other energy-saving technologies, the electrical demand may be reduced. This reduction in demand should be reflected in the demand factor calculation to accurately estimate the building's electrical needs. The demand factor calculation is not a one-time task. It's an ongoing process that should be reviewed and updated periodically to ensure that it accurately reflects the current and anticipated electrical loads. By regularly monitoring and reviewing the demand factor, it's possible to optimize the performance of the electrical system, reduce energy costs, and ensure that the building's electrical needs are met safely and reliably. In summary, calculating the demand factor for offices in high-rise buildings is a complex process that requires careful consideration of various factors. By gathering accurate data, selecting appropriate multipliers, and accounting for future changes, it's possible to develop a reliable demand factor that accurately reflects the building's electrical needs. This demand factor can then be used to design an efficient and cost-effective electrical system that meets the building's requirements safely and reliably. It's also worth noting that some jurisdictions may have specific requirements or guidelines for demand factor calculation. It's important to consult with local authorities and electrical inspectors to ensure that the demand factor calculation complies with all applicable regulations. The calculation often involves understanding and adhering to specific local amendments to the NEC or similar codes. These amendments may reflect regional differences in climate, building practices, or energy policies. Compliance with these local regulations is not only a legal requirement, but also ensures that the electrical system is designed to operate safely and efficiently in the specific context of the building's location. Furthermore, the demand factor calculation should take into account the potential for future expansion or changes in the building's electrical load. As the building's occupancy or activities change over time, the electrical demand may also change. It's important to anticipate these changes and to incorporate them into the demand factor calculation to ensure that the electrical system is adequately sized for future needs. This may involve adding a safety margin to the demand factor or designing the electrical system to be easily expandable. The accuracy and reliability of the demand factor calculation depend on the quality of the data used and the expertise of the individuals performing the calculation. It's recommended to involve qualified electrical engineers and other professionals with experience in demand factor calculation to ensure that the calculation is performed correctly and that the results are accurate. These professionals can provide valuable insights and recommendations based on their knowledge of electrical systems and building operations. They can also help to identify potential risks and opportunities for energy efficiency improvements. In addition to the NEC standard, there are other resources and tools available to assist with demand factor calculation. These resources may include software programs, online calculators, and industry guidelines. However, it's important to use these resources with caution and to verify the results against the principles and guidelines outlined in the NEC standard. The NEC provides a comprehensive framework for demand factor calculation, but it's not a substitute for sound engineering judgment and expertise. In conclusion, the demand factor calculation is a critical step in the design of electrical systems for high-rise buildings. By carefully considering the various factors that influence electrical demand and by involving qualified professionals, it's possible to develop a reliable demand factor that accurately reflects the building's electrical needs. This demand factor can then be used to design an efficient and cost-effective electrical system that meets the building's requirements safely, reliably, and in compliance with all applicable regulations.